Okay. Great. So for the beginning, I will be happy if each one of you, just like in less than a minute, will say the main things you want to talk about this hour. So I will try to integrate and to make it organized, efficient for the next hour. So Christian, maybe start.
Okay, Ron. I would like to check my problem about the code fit. Yes.
The problem of what? The curve fit?
On my code fit. Yes.
Okay, great. And Simin?
Probably like the next steps and also like the official information, the CRLB stuff. That's I'm not so sure about, yeah.
Okay. And Aditya?
Yeah, the thing is that understanding math for at the end goal, the optimization of the algorithms.
Okay. And okay. So I will be happy. So we will split into the theory, math talking, and the technical part. So I think the best is to start with the technical part. I will be happy that all of you are invited to share. It's not must to be all of you, but at least we want to see the code. You can also share this code. You can use together the same code. So Simin, maybe you start to present what you did. You did something very organized. And if you can share the screen, tell me how you built it. We can learn together, and we will speak loud and understand how things are working, how we code in Classic. And you're welcome to ask questions. And if it will be good and complete, we can align together to this code. If you want, you can integrate the other missing part together from the other part. But let's start with this as a reference. Maybe step by step, you can explain what you did.
Basically, I used the code from like the Classic website and I copied it. Then afterwards, I edited it. Okay, so firstly, the first one is using a phase gate so that we can control the phase. So I changed the gate, the U gate to be a phase gate for that one, for the first function. The second function is it's more or less the original code from the website, which comes from the poly gates. Yeah. So it also generates all the results, all the counts from there. Then I also have like functions to like process the counts to change it to Y in the short.
Sorry, Simin, just before the next part, I will be happy to talk about the part of generating the circuit. First, the question to everyone, do you understand what Simin did? Do you feel comfortable with creating such a circuit with Classic? Do you have questions about it?
In my case, I have read and see some example in Classic. Perhaps I understand what Simin is doing, but of course I have to go deeply on the example because some technical thing I don't understand, but I don't want to get longer the conversation on that. I think I can go on then by myself.
Okay, perfect. And just a comment for you, Simin, it's looking very good. You did it with function very nicely, very short, just with, this is the nice part of the most useful thing of using Classic, that in a very small amount of lines, you can define your model. You don't need to define gate by gate. You define the model and you get what you want. And the nice thing behind of this code, which you are sometimes not aware, is that Classic is calculating the most efficient way to implement this mainly phase estimation here. Because under phase estimation, there is like a tree of options of how to implement different things. Options of how to make, for example, the Toffoli gate. You have a multi-controlled X gate. It's something that comes a lot. And there are different ways to implement it. It's needed inside the QPE part, and you can choose if you want to optimize the width, you can optimize the depths. Here we didn't define the constraint, you just give the default constraint, but you can also read in the user guide how to define constraint. And Classic Engine is optimizing and giving you the most efficient circuit you can ask for the defined model. So you define the model only in a high level. You don't need to be aware of the compilation, which is like in classical code. You don't need everything. You just want to be the most high level and to get the best, most resource efficient result circuit. So great. And just a comment for you, Simin, there is two different functions that look very similar. Perhaps you can unite it to just one function and maybe to give one more parameter. The parameter is saying if you want Pauli or you want the phase, then change only the inner part, which is the only different. This is more, will be easier for you to code this way, but this is just a recommendation.
Actually, with regards to that, right? Actually, I don't fully understand this code partly. Is that there's quite a few items that I don't really understand. Like for example, the phase one requires this to be a target, whereas this Pauli one requires this to be an in bracket 0. So like that kind of thing is, I'm like, what if I want to use other gates? Then how will I know which one to use?
So the in wires. What's the difference? Why it became different?
I'm not sure, but I think it has to do with like the Pauli the sky state is 2 qubits, and then the space one is 1 qubit for the sky, the one that doesn't change, I think. But I'm not very sure. It was just recommended on the Slack channel to change it. Because
okay. Anyway, just a recommendation. If you click inside the phase estimation, and you go the implementation of phase estimation, I'm not sure if it's possible in Jupyter or in, but in PyCharm, when you write a simple Python file and you do like control click on a function or an object, so we can see how it implemented behind in our library. And then there is a function, I think the name is output the name, something like that. You see the definition. It has definition of the names of each function has names for the output and names for the input, and you can see it there inside.
okay, I'll look into that. Yeah. Then shall I move on to the next part and talk about what else I did?
But I just something about the names. It sounds really maybe not very comfortable to code this way. So if you feel that you have something that you know how to change, which will be more user-friendly, I welcome you to write it in the feedback channel. It's very, we read everything and we treat everything correctly. Okay.
About the target and in thing, is it?
Yeah.
Okay. Then shall I move on to the next part?
Okay, just sorry, just again to the first function, I will just shortly say that, look everyone, how it's done. You synthesize the model, so you get the program. Then when you execute, you get a job. The job is like an ID, because you send it away, you can go to sleep, make some coffee, return with the same job ID. Because sometimes it takes time if you send it to real hardware. And then you can take this ID and to ask the classic cloud, okay, I have this ID, what is the result? Do you have a result yet? Or maybe the processor, the quantum hardware didn't finish to run yet. So you get the result. This is a list of results. It depends on the classical model inside. In this case, you get only one result. Result in the 0 place in the list, the value of it, you get the counts of it. You can see past count, and now let's continue.
Okay. Basically, I also wrote like functions to like process the counts from the previous one, and also to generate like a histogram to scatter the plot. And then afterwards, there's this curve fitting parameters, which both fits the curve and also finds the parameter to fit the curve. So like I have this function and a function to find the probability, and then basically do a curve fitting and then generate the fitted curve. Yeah, so it comes out like this. I'm also writing notes, so sorry if I'm not looking at screen.
It looks very good, but here, did you find the theta or you used the original theta?
Yeah, this is the theta that the curve fit found.
Where is the function that finds the estimated theta?
Yeah, in this fitting curve parameters, this parameter here from the curve fit.
Yeah, but
And
in this part you didn't have. There was the problem that sometimes you guessed the wrong one from the other side. So I recommend you to do 2 guesses.
oh yeah, that one I didn't do because I'm not very sure about that right now. I don't like, maybe we could discuss that because I don't really understand the 2 guesses thing.
Okay. Because can you show a plot that was incorrect? Because
The
you
thing-
showed-
The thing is that I can't get the incorrect plot right now. I was trying to find the incorrect plot because but now I can't get it back.
maybe it's depending. What was the initial guess? I will just to tell. Maybe you have a picture of it. I just want to show you to Aditya. Are you here?
Picture. I can open the Slack, I guess. I think I lost the picture. It's like, oh my gosh.
Yeah, I just want to show Aditya and Christian the phenomena. Did you see the? Now Simin will show one picture. Is better than words. Okay, yeah.
This
This one, yeah, great. So as you can see here, this seems weird. Why curve fit guessed that this is the curve? Because it's not have a good fit with the data, right? But you can see that if you there is a fit on the other dots. But if we were guessing, we start our guess and the search and optimize algorithm will start from the left side, so it could lock on the correct points. So what we did in Classic, let me share screen also. I'm sharing. I do a window screen. Okay. Can you see my screen? Okay. So to solve this, what I did is 2 guesses. The first guess is starting from above is starting from the right side, and the second guess is starting from the left side, and I'm looking for the smaller one. So I return the one with the smaller covariance. The estimation with the smaller covariance. That's it.
Oh, I see. But right now, for some reason, like, cause I was trying to get the wrong one again. Then I if I have no initial guess, then it gives me an error. Like, it gives me no optimal parameters found or something, I think.
Yeah, because initial guess will be good. It's easy to give initial guess. You can just take the highest point, but sometimes maybe you want to start a little bit from the left or from the right. It will be also faster because maybe it gave you error because the search was too long. It didn't reach the estimated theta because it reached maybe the maximum amount of tries to look for something with a good fit. So initial guess will be good, and you can also play with the parameter of the curve fit, but we have to play with complexity. You can tell the curve fit, I want this resolution for my solution. I want to limit the maximum amount of cycles, which is searching for the estimated theta.
So
Yeah.
just now you mentioned like taking from the maximum, then a bit to the left and to a bit of the right. Like, do you have recommendation of like how far or like about that? Or should I just arbitrary number?
You can try by your own what you like, but what I took, the first guess was the highest one, and the bound, the maximal going left and maximally going right, I took like just a moment. I took half of the size of the bar, because you have like 8 slots from 0 to 7. So I took it from 1/2 plus and 1/2 minus.
So that number, then half and half, or is it one
Yeah.
and a half?
Yeah, because it's not possible that the maximum, the theta will be too far away. It must be somewhere between those two slots.
Okay, thank you.
You're welcome. And anything else you wanted to show in the code?
Oh, nothing, I think, yeah.
Okay. So that's it. And what are your next plans for coding?
Right now I'm thinking of, okay, one question I want to ask is that is right now the accuracy, like, okay, I think it's quite far off, right? Because it's like 0.333, then after it's just random numbers already. Whereas it's supposed to be 1 out of 3. So I'm thinking like, should I be improving the accuracy on that? Like maybe like checking into the least squares function on that, or should I be doing another method about it?
This method is supposed to be good. It's very generic. It is using least square behind the scene. The accuracy parameters, there are few accuracy parameters, one for the derivative and one for the value itself. I didn't go deeply inside. You can try to play with it. My intuition that you need to ask for the resolution that you expect to give something which is like whatever you like, whatever you want. But here it's very trying to connect with the theory part. If you saw the CRLB article, so you can try and start looking on the accuracy as a function of the number of iterations or number of shots. Also the counts, right? You chose how many counts, how many times you run the quantum circuits. It's also a parameter. Perhaps you need to run it exponential time to have a good fit. So if you want a resolution of 1 to the minus 10 to the minus 10, for example, so perhaps you need this amount of shots, 10 to the power of 10. So this is something that worth exploring. But this is a very advanced stage of the code. This is you have a very good structure to take and to start to play whatever you like by thinking of theory at the same time. You are in a stage of the project that you can start to ask yourself the research questions of, okay, what do I want to show? Perhaps to use the dual frequency article as a reference. Yeah. So maybe until the end of this meeting, we have more clear view to the next parts.
Yeah, thank you.
Anything else, Aditya and Christian, about the code? Do you want to share what you did, ask questions? Also, maybe talk each other, like how to integrate code together before we move to the theory part?
Can I show the example I'm following for matrix eigenvalues just to see
Yeah.
what I did on the curve fit, please?
Yeah.
So I was looking for an example to work on QP because, as I mentioned before, one of my challenges here is to get more into the programming things because I have several years that I haven't done anything of programming. So I have many things to understand at this point. I would like to just to say that I found these QPE for matrix eigenvalues very useful because I was thinking to work on the general part. I mean, several phases case. But now you mentioned in the Slack, Ron, that we should focus on the single phase part. So my first question is just why only in the single and not the multiple part phase part. So regarding what I have done,
Just maybe we want to talk about this now. There's the single eigenvalue and the multiple eigenvalue, two different cases. I'm not saying you whatever you feel you want to focus on, this is your project. I'm just here to guide you. If you feel you want to go to this way, it's okay. I just thought that you have to define what is the final target of your project, because you are almost like the half of the project, and I thought that a reasonable and decent target will be to examine, in theory, to examine how this method is used, because this is something that this is the first part. This is the first time such an analysis is done. It was done in a little bit different approaches, but in this approach of post-processing, was first time, and the simple case seems to be reasonable to explore. But perhaps say also that you are three people, maybe you want to split the work together, maybe you want to explore the possibility of more than one eigenvalue. And this is welcome. You can go to this way, but you have to notice that the algorithm here should be different, because the optimized algorithm has to search. In the simple case, it's just searching for theta. Theta is just one dimension scalar from 0 to 2 pi. You can search there and you can find it. It's a very well-defined algorithm. But in the multiple cases, you have to search for, if you have three eigenvalues, for example, so you have 3 dimension from the phase that you're looking for, and there is 6 dimension. There is another 3 dimension for the amplitude. So the algorithm is becoming more complicated. You are more than welcome to explore it. I'm not blocking you. This is yours, your project, whatever you want to do. But this is my recommendation.
Sure, thanks. Okay, yeah. So just to show you what I have done this week. So after learn a little bit about the example, I try to fit our probability to the sample of data given by the algorithms. So just to mention something about the values of the horizontal axis is that the negative values is because the example normalize the data just to show the exact value of the eigenvalues of the matrix, the given matrix. So if we don't normalize the data after the QP algorithms, we can recover just the histogram from 0 to the number of qubits, like in this case, but this is an example for 7 qubits. So that's not a problem from this example. This is an example for a matrix with 4 different eigenvalues, and from using 7 qubits in our control register.
But
But
if you normalize the x-axis, you also have to normalize the probability
the function. Mhm.
function also the same way. Okay.
Yeah, sure. Okay, so I tried to make a fit using the single phase case, but after that, because of before I did a simple code for the multiple phases. What I tried to do was to fix my general probability to this example, because in this case we have 4 different eigenvalues. So perhaps what I did was to fit this function. I excuse because this is a mess. I'm not an organized programmer, but this is just an example using 2 phases. Yeah. So there are 2 values for theta and 2 amplitudes. And what I did for the curve fit was to, according what I understood on the future, the attributes of the curve fit, because I didn't know that. I put the bounds for the parameter Simin showed us, and just following Simin's work, I put here the couple of guesses for the value of y, that is the 2 highest values of the sample. But unfortunately, I haven't gotten good results. So sometimes this red, that is the fit curve, increase a little bit around these points. But sometimes, like in this case, this is completely wrong. Nothing happened with my data. So I don't know what more to do here. But one of the activities I want to do this week is to look at the Simin works, that is very organized, to try to understand a little bit more this fit part. I hoped at the end of this week to have something better, but of course, I know that we have to work in the theoretical part. I mean, on the Kramer-Rao lower bound. So I have started to read the reference 26 of the dual paper. That is an old book regarding the estimation processing stuff. But I don't have a really good copy. I found some copy on the internet, but there are some bad parts. I mean, it's something like this one. Let me show you. Okay, I don't have the book here, but I would like to read. I don't have the PDF here, but I have an old copy of this book, reference 26 of dual paper. And what I'm going to do this week is to read deeply this reference to start to compute the CRLB. And that is what I'm doing. I was playing a lot on this QP example. And as I mentioned before, some technical thing I don't understand well. For example, I'm trying to follow the tutorial, the classic tutorial, to understand how the phase estimation works, and I hope to get a deeply understanding for the next for our next meeting. That's all.
Okay, looking very good. So few things. First, about the code that you wrote. You said you will use look at the Simin code as reference. This is very good. I also recommend you to do the other way, that let someone else, Simin or Aditya, to look at your code and to try to help you to find any maybe small bugs, maybe something, any advice that is more algorithmic. This very good if you are coming to the project also to practice programming. This is a method that's called code review. Well, this is also the way that developers work also here in Classic. Any code that I write cannot be merged into the main project before someone is making me a code review. So you can try to get used to it. In Git, there are some tools that you can do it also very easily. So someone can give you a comment on a specific line. Anyway, shortly, I recommend you to give someone else, and this way you also learn from each other what you did. And another thing, another advice beside the code review is debugging, which is also a very important tools for any programmers. You cannot code without debugging. Debug is let the machine read line by line in your pace. You have a button, you click OK, now go to next line, and you can look at the values of each one of the variables and follow and understand what is done without looking it like a black box. So I welcome you to, this is a very good opportunity to learn to do debug. The problem in Jupyter Notebook in this format is that it's hard to do debug. I never done debug this way, maybe sometimes, but it's easier to do it in a regular Python file in PyCharm. This is very easy. You put a breakpoint at the line that you want to stop. Instead of running, you run in debug mode, and you do line by line. They are very beautiful and nice, powerful tool, and this is the opportunity for you to learn. The third advice, my guess, if there is no bug with normalization or anything, that maybe the parameters of the curve fit, the resolution parameter, maybe they are too big, because here the algorithm has to work very hard to find the very specific values, and maybe it's exhausted too quickly. So look at the parameters that curve fit, and instead of letting it, taking the default, maybe try to change it. So you can click again at PyCharm, you do control-click on curve fit, and you look at the internal implementation of curve fit, and you can see the other parameters. For example, let me show you. I share my screen. Doing sharing. So here you see curve fit. Specifically here, in Mac it's command, and you click. So what I mean here is that, for example, here are the parameters, method. You see ftol and xtol and gtol, they are the resolution parameter. I think this is the derivative, this is the y values, and this is the x values. And if I go here inside again, how did I find it? Why no? There are sometimes keyword args, which is option to give more parameters, but then you can also look online. When you write curve fit in Google, you see forums, they talk about curve fit and they explain everything. And so here, let's go list square. You see it gets the gtol, xtol, and ftol, and it has some default values. And maybe also max f evaluation, it's the maximal amount of calls to the function, maximum amount of iteration. It's also as default. Anyway, this is my 3 devices. I do stop sharing. Okay, and this about the code. And we will soon talk about the theory part. Aditya, do you want to talk about the code part before we move to the theory part?
No, I saw the code and I will be, my side, I had made a local copy of Siemens code. I will be looking at that and maybe trying to optimize what Christian is doing with a curve fit.
Okay. Uh,
Regarding Christians, I have something to mention is that, okay, to be honest, I don't really understand it, but it's like they are finding eigenvalues for the matrix. So isn't it likely that there's more than one eigenvalue, so more than one phase in the first place? So the general case must be used, and also like the general case, like there are more than one and more than two most likely, right? So is that one possible reason why it's not fitting? So I think the matrix I'm seeing here is like 4 by 4.
I'm not sure if I understand your point, but so well, like I understood this example is that you have a matrix. Let's say that you have, in this case, this is a 4 by 4 matrix, but you can give any dimensional matrix. If you assure that you have different all the eigenvalues, you have the same problem in the QP estimation problem we are working on. Because for any eigenstate, you have a different value, and that value is related to the phase we are looking for from our probability likelihood. Yeah.
So with a 4 by 4 matrix, you would have maximum 4 phases. Right.
Okay. Yes, in principle, for the example I did, there are 4 thetas. But what because my curve fit was not good, what I did was to work on the 2 highest eigenvalues. So I tried to make a fit with just one phase around the highest value of the sample, and then using 2 phases and 2 amplitudes around the 2 highest points in the sample, because the highest point is the highest eigenvalue in a decreasing order. But if you choose the data from your sample, you can choose just 1, 2, or 3, or the 4 eigenvalues that you want to fit. Yeah.
Yeah. Thank you for the explanation. It's very interesting. Yeah. I understand better now. Yeah.
okay, great. So anyway, again, you can make one repository, one Git repository that you share code together. You can do things more organized to use just one function of the curve fit, and another one for the curve fit with multiple cases, and one script for each one. Like, you can design it however you like, but maybe it will be more comfortable for you to build the code in a way that you help each other to make it better instead of the separate. So far it was just playing to understand it, but maybe now it will be easier to do one code together. If you also want to try Git tools, you can also discover that you can edit the same file together. You inject a function in one line, and the other one can inject a function in another line. And we are working in Classic 40 people on the same files, and we work together, and it's okay. There are no problems. Sometimes when there are conflicts, we'll fix it and we'll continue. Okay, so this is for the code part. So great, you did a very nice work. I'm happy to see the progress so far in the code, because now you have a lot of time to deeply explore like what's next, what you want to put in your article. Just to think about the schedule for 1 minute. So you're supposed to write an article in 1 month, right? Do you know the schedule? Maybe I have it here.
If I remember well, it's for January, the 1st or 2nd week in
It says
January.
January 2.
Yeah, I think so. We finished half a semester. Mm, mm, mm. Okay. I'm sure there was like a schedule somewhere. Just a moment. QCourse. Okay. Before we move to theory, we have 15 minutes, so but this is the next part, so it's okay. Let me share screen again.
It says 23 January, the last session. Mhm.
Yeah. Paper writing is in this stage. Okay, so we are good. So it's good time to explore, to have deep knowledge of your project and to go on. So great. So let's talk about the theory part. Who would like to start? Christian, maybe you want to tell again, like, what are your plans? What would you like to do? I think that in the current situation, you're maybe most seeing what is to do. Maybe you can help each other to lead and understand what is going on and how to do it. If you like, we can also open the article and talk about it together if you like.
Yeah, sure. So I'm going to share the screen. Yeah, I found the book I was speaking before. This is this is the reference 26 of the dual paper. So this is fundamental about estimation theory, and in this three chapter they do all about the camera bound. Yeah. So I'm reading these references, but I have to say that because I was working a little bit, a lot on the algorithm, so I stopped my reading here, but I'm going to return it this week. So I from the paper. From the paper, just speaking about this theoretical part, I already understand that in our case, we are not going to make use of, let me look for the approximation. Oh, okay, yeah, this equation. I'm not going to make use of any approximation like this one for our likelihood. What is our likelihood? The probability function in terms of theta, m, and y we have computed. I think that the next step is to compute this feature information, because according to our feature information, we can estimate the Kramer-Rao lower bound for our estimation protocol. So according to the reading of the mentioned reference, I just realized that there is an original definition for the feature information that is not this one. So I have to clarify that, because in that book, the feature information is defined as this error, let's say, yes, error, but on the second derivative of the natural logarithm of the likelihood. But in the third chapter, they speak about different ways of computing the feature information. So I have to read and clarify what is the best better option to to use in our case. But like a question, I would like to know if, for example, because we are following this paper, we can just simple try to compute this expression here that they say it's an alternative way to compute the feature information. So any independent of the way we compute feature information, like from the book or from this paper. So what I expect that is that to have any expression for this feature information for the next for our next discussion. And after that, as I see the progress, I would like, for example, to extract this point, this data from this paper. I'm not sure how to do it, but I would like to extract this point and to make the fit, for example, as Simin did it on this particular samples, this data, just to compare our result with directly with this reference. Hmm? Yeah, that I haven't done anything else about it. Mm-hmm.
Okay, very nice. So another part of this, of the mathematical development of this part, can be like just testing, because as Simin did, she took some phase. She know which phase to accept. She ran. She gets some phase which is a little bit different from the phase she get. And you can start to run and to build graphs that say, okay, for this number of shots and for this size of register, I can plot a graph and show how accurate my result is, and to do like Monte Carlo and a lot of plots for different parameters, and to get a lot of data to test and to see how you extract it. You can, of course, you can also do it on a real hardware, but maybe simulation can be enough here. And to plot it on the graphs and to compare it to the theoretical analysis. And Christian, if you go down more to the next page in the article, a little more down, I don't really remember exactly what they did. Next page, please. Yeah, here. So this is a nice analysis which saying you can do it as number of samples, for example. So you can see and ask yourself, how many samples do I need to get the best estimation? As I do more samples, I get better estimation. So maybe you can do graphs like this and you show that you have better results, for example. So there are many directions here. I think that maybe we talked about things that I don't want to tell you exactly what to do. I'm also honestly not very sure exactly what to do, because there are few possibilities of how to do the work. I welcome you to decide together how to split the work, because there are different approaches of going here, and you can take it whatever direction that you like. Maybe also to the multiple eigenvalue option, which is another option. So perhaps maybe I personally will finish here the meeting. Maybe I will let you to use this virtual room to talk together and to plan your next steps. If you would like to add anything before I tell you goodbye, you're welcome, yes. And after when you finish, I will be happy that one of you maybe write some message in the Slack so I can see what you decided to do.
Thanks, Ron. I want just to mention that This is the first time I work like in this methodology, interacting with other people. So no, perhaps the major of my previous work has been quickly alone. But I have to say that because of other activities, it's a week is a very short time to make a progress and to organize a meeting with the team. So, but I would like to speak about it because, as you said, the deadline is close, and we have to. It's better if we divide our development to then enjoy the results like a team. But I just wanted to mention that to make progress every week is something new for me, and and I'm trying to separate this project from all my other activities. But it's okay, and I'm happy to be here. Yeah.
Sure. Each one of you has its own constraints, different constraints. You can define targets for 2 weeks instead of 1 week. And for the meeting next week, the meeting is not with me, it's presentation. You just can look at it, okay, just 1 day before, let's think what have we got so far, let's put it on slides and show it, and this is okay. But the final target is to look at the end of the project, the end of the semester, the article. This is what's important. And each week, the weekly progress is just a small picking of looking into just asking what have you done, and this is mainly for you to help you to understand how to continue. But each one has its constraints, and I understand it, and we are not like micromanaging anything. We are here for you. Okay, so I'm the host, so I hope that it will not finish the. You know what? I will maybe when I go away, maybe the meeting is over. Let's try. I will say bye-bye, and I will join again to the link in a few seconds to see if it's okay.
Oh yeah, we're still here. I mean, he's joining in a few seconds, but also, do y'all want to discuss what we want to work on?
Is this okay? Okay.
Yep, it's still okay. Bye. Thank you. Do you want to discuss what you want to work on for next week or so? Yeah.
So, following our discussion, I think that my main task for this week could be the calculation of the feature information. If you agree? Yep.
Yeah.
I would like to have an expression for the feature information of our probability distribution. I hope to do it, but I would also like to cooperate in the algorithmic part.
By the way, do you know how to incorporate the feature information with the technical algorithm part? Like, I don't understand the link there.
The feature information need just to make the theoretical analysis on how better is our approach from other ones. Yeah.
Oh,
It is independent in principle from the algorithms because according to the definition of feature information, we can compute an analytical form. But after as I understand, after taking an expression for feature information, we have to test our Kramer route bound in different samples. It's like Ron said. For example, we have to make some plots like in the wallpaper, figure 7, 8, and 9, and to compare our feature information behavior.
I see. Thank you. Then, okay, so do you guys think I should continue working on like improving the current value? Because right now it's like I do like 0.333, which is not actually very good. So like, should I work on that? Or do you think like, I was also thinking the option is, are you all interested in doing more of the general case on as an extension? If you're very interested, then I was thinking that I think your one looks more applicable for a general case because it's like you have the direct matrices, whereas mine is just one phase gate, you know? Yeah, so I was thinking that maybe this week I could also like look into your code and try to understand that because currently I don't actually understand it. Yeah, then maybe we can look at how to get the curve fit better together.
Let me ask you something regarding what you did. Did you test more qubits for your samples? I mean, for example, using 7 qubits and more.
I let me just share my screen. Actually, I have it like it's wait. Okay, where's the code? Yeah, I did test it. It's down here. This one is I think it's 5 qubits. I mean, I can run the code. This is 5 and this is 7, which is very tiny, but I think you can. Are you able to see it's like still quite good? If not, I can send it to the group if you guys want to look at it.
Because of course my code is a mess, but when I use a few qubits, for example 3, I got some similar behavior like yours. But when I put more qubits, it's completely wrong, the fit. So I would like to know if in your code, if you have similar problems or not regarding the number of qubits.
Yeah, I don't have because I have an example is 7 qubits and the fit is actually quite good. I don't know if I can expand. Can you see my screen right now?
Yes, we are looking at the
Yeah,
conversation.
this is 7 qubits. The fit is still quite decent, but I think mine is quite different from yours. The thing.
Excuse me, Simin. We are looking your screen, but our conversation, the meeting.
Oh, okay, sorry. Then let me try reshare the screen.
Sure.
Oh, I clicked the wrong thing there just now. Yeah, okay. Are you seeing this now?
Yes.
Yeah, so this is 7 qubits, so the fit is still quite good for this method. But of course, mine is much simpler. It's just a phase gate, whereas yours is a whole matrix, so that might be one reason.
And okay. So it's good. Your feed is works completely well.
Yeah, but it's just for the phase gate, so that might be a reason. I was thinking that you said that like the highest one will be taken in your case, like the most prominent eigenvalue. Do you think that it's still possible that the other eigenvalues are like close enough in like likeliness that it will affect? Is it hanged? Oh, it's hanged. Oh, basically, do you think that the other values could be like of a high enough value to like disrupt the whole curve a bit? And since you're only taking the first and the second situation, like maybe those are causing issues, for example.
I'm not sure. I think I'm not understanding what you mean.
Okay, because yours like it was the matrices, right? It was a 4x4 matrix. So there's theoretically like 4 phases most likely. Could be less, but and then you were saying that because you only fitted for 1 or 2 values, so the highest ones will be taken, which I understand. But will it be possible that the other values are like a high enough value in relation, like relative value, to cause a disruption in like the values overall, and such that the curve has trouble fitting, for example? That'd be a possibility.
Yes, and in one of my example, I got that situation you speak about, because in my matrix case, all the higher values are the higher points are different eigenvalues. So I expected in my case to have a different maximum for our approach, but because of, I mean, perhaps due to the let's say the attributes of the card fit that I'm not sure how to fix them. I'm not looking that. I'm looking just the overall course fit for the points above the others. But I think that, for example, that is something that we could test from your algorithms. If you extend your algorithm, for example, to 2 phases, we can see if you have the good results, and you can distinguish from the points according to the phases you have. It would be a nice technical thing to test. Mhm.
I think that currently mine cannot, and I think this might also be a bit applicable to your case because right now my probability function only allows for there to be one maximum value like that, like yeah, because that's the probability function which I gave it to fit. And then yours, I think so far I only saw a 2, the case where there's 2, but there's no case of 4. So maybe we want to try a case of 4 for yours also, maybe. I don't know. Yeah.
Let me show you. So in the case I'm working on, because as I said, I found this example useful for the multiple phase case. Is what happened here is the following. This any increasing of these points, for example, these points represent in principle and specific eigenvalues of the matrix you give. So that means that this part in here leads another eigenvalue, and perhaps this point here represent another one. For example, in this case, we have 3 different eigenvalues. So for sure, if but sorry, but this is not working. Perhaps I'm going to show you my report. Yeah, okay. So here, this is the same case, but just for 3 qubits. In this case, in this specific case, this corresponds to a different eigenvalue than this one. So in principle, this card fit is no good because I'm fitting using only one phase, right? So the fit is made like if these two higher values corresponds to the same state. But after that, what I did was to extend to add the second part of the probability function, just to add another phase. So in this example, I fit the data using 2 phases and 2 amplitudes. Yeah, but what I got was this overall curve that I think is because these 2 eigenvalues are very close to each other, and there is no enough number of data among between them. Perhaps this is the problem. Of course, from the example, I don't know how to test or to extract more points around these ones, because I don't understand completely well the algorithm. But for example, if in your case you you run the QPE algorithm using 2 phases, what I expect to happen is that you have a maximum, a local maximum around this point, and a different local maximum around this one. And what I have to do in your algorithm is to add another. Let me show you here. Okay, perhaps. in the
By the way, is this set of code on the repository? Because I think I want.
no, yes, but it's an older version there.
Oh,
I'm going to update it perhaps between today and tomorrow.
Okay.
But in principle, this function is the same you have in your code. And what you have to do for testing multiple phases is to add another line like this one, but with a random, a free coefficient
Alpha.
here, that is the amplitude. But into the fit parameter, you have to add 3 more parameters to test, to fit, because you have the same phase, the first phase, and you have to add another one. But adding this one in your function that is the same form, you have to add these 2 amplitudes, because this amplitude, this corresponds to the amplitude in the superposition of the 2 eigenstates, giving the same phase, the corresponding phase. So in principle, if you add this one in your code, these 2 amplitudes for any line you have in your code, you you would expect to recover the multiple phase chord fit.
Okay, then actually I have 2 questions. Firstly, you mentioned this one, right? So I just basically add just now that 2 probabilities, except I need to multiply it by this coefficient and the t. So like just add the 2 probabilities together for the curve fit. Is that correct?
Sure. Well,
Okay.
yes, it's correct. Yeah,
Oh.
here.
Then my
What you have in your code is this expression, yeah. And when you add more phases, you have to sum other expression like this one, but not with 1 here, but a different coefficient for any term you add.
Right.
So if you look here, for example, let me see the general part. For example, in here, yeah, sure. This is basically the same expression, but with different coefficient here. Yeah. Oh, sorry. This is the density matrix. I mean this one, this expression. Yeah. So
Yeah.
the sum here is on this subindex k, but this k change according to the number of phases you add. So, for example, if you have just 1 phase, this one phase, this is 1, and you have only 1 expression. This is the case you already have. And if you add another phase, you have 2 different coefficients here, A1 and A2, and you have 2 terms like this one, but with different theta here.
Oh, okay, thank you. Then just to check also, right? Just now you had 2 alphas, but actually the 2 alphas, each of them squared should add to 1, right? So actually we just need 1 alpha, right? And then we can calculate in the algorithm the second alpha.
Alpha, what do you mean
The
with
coefficient?
alpha?
The
The
coefficient,
A.
the A.
Okay.
Yeah, like that one squared, all of them sum together squared should add to 1, right?
Each one, yes. No. The square is because this coefficient comes from a superposition. Yeah. So these coefficients are complex numbers. Sure. So basically, when you compute the probability, you get the norm, the square of the norm of the complex number. Yeah. Sure.
Okay.
But for example, they are not completely free because they come from the superposition. And one constraint you have to take into account here is that the sum of the square of the value of each coefficient, the sum of them must be 1. So, for example, if you sum over k just for this expression here, just this square expression, the sum must be 1.
Okay.
Right?
Yeah. Thanks.
But
I also wanted to mention, right? I'm not sure if the curve fit currently takes into account any complex numbers. So we might want to look into that function, whether it can take complex numbers. Now you mentioned this.
No, sure. But what I what I think it's possible to do is that just to consider the
Oh,
square
just
one.
square. Oh yeah, true.
Yes, like you can consider just a real number that represents the square number of the square of this amplitude. Yes.
Oh yeah, that's true. But so basically we only need one alpha to represent two because we can just one minus the first one squared, right? And then square
Yes,
root.
sure.
Yeah, I think that might
Yeah.
help it with the algorithm perhaps. I'll try it out at least. Yeah.
Okay.
Yeah, so I'll look into that. Look into like improving the accuracy. I'll also look into the your code for like in more than one phase. So I think that's what I'll try look into.
Mhm.
Yeah. So I did yeah, I want to mention what you plan to do this week then.
Yeah, so actually, I sent you a request for the GitLab access also on the repository. Other than that, I will be, first understanding the math, then trying the coding part, because the thing you mentioned about using like Fisher information in terms of algorithm coding, I found a paper by Facebook Research on measuring data leakage in machine learning models with Fisher information. So I found their repository in which they implemented Fisher information with a Python file. So maybe I'll add a fork with that if we can use it in our code also.
Oh, are we using Fisher information in our code?
You tell me actually that you talked about using it in the previously with Braun.
Sorry, I get lost. Could could you Aditya speak again about the what you mentioned about machine learning
Like
and
I will
Fisher?
like in the code implementing Fisher information later on when we uh,
Sorry. So you say you have a way to implement Fisher information using machine
yeah,
learning,
yeah.
or
Actually, the thing was that you asked Ron about using the Fisher information in algorithm. So I was talking about like when we try to use it in our code. So I actually found a repository where they used Fisher information through Kramer Rao bound, and they made a Python file of that.
Can I clarify? Do you mean today, like what we said just now? Like you said, like I mentioned using it in the algorithm. I'm not sure when that is. Do you mean that? No, I'm not sure when you mean when you said.
Yeah, in the meeting earlier, I think someone mentioned like using Fisher information in the code repository we're working on.
Okay, I was discussing that with Christian. Basically, what I asked was, how do we link the Fisher information with the algorithm? And Christian gave quite a good explanation that we're not actually implementing it in the algorithm. It's more of the Fisher information provides a theoretical analysis of how much better our method is. Yeah, rather than implement it in our code.
Oh.
I think, right? Christian perhaps may have more to
yeah.
add.
Yes. So I mean that we have to get an expression for the Fisher information. In our case, so using our probability distribution, our likelihood, uh, that is a mathematical development that then we can test and we can use to to test the Kramer-Rao bound for different samples. But before doing that, in an algorithm, we have to get a mathematical expression for the fi. That is, I don't have it. That is the what I propose to do to start to do this week.
Okay.
Because that is important to know how good is our approximation. So you have a sample of data and you make the quantum phase estimation processing, on that data. So you estimate a value that in our case is a phase. But how good is our estimation? So a mathematical analysis for doing so is computing the 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 meaning covariance according to feature information. So we have to compute feature information to test that. Mhm.
Okay. Then did you have anything else you want to try?
Also, I had a question. Like this meeting is being recorded, but only the host can access the recording. And if Ron has left, like who would get the file?
That's a very good question. Um, maybe when we end, maybe it'll just get sent to him. I hope.
We can message him to join for like a second or two and like get the recording file.
But he's with the other group now. That's the thing. Okay. Then that. Do you have any idea what you want to work on? Yeah.
Well, like I'll try to first understand the math behind it, but like if you want to divide some work that you want to assign, maybe I can work on that at first. Like in the GitLab repository that we're working on, about Ron, said maybe adding different codes and exploring different venues in terms of that.
Wait, which venues exactly are you thinking of? Then do you have any idea?
Not at the moment, no, because I actually just came back right now. I did not have any, previous information about it. I was at bed rest for a couple of weeks. The climate here is not great right now since there's a lot of pollution coming in due to the seasonal effect in the neighboring states.
Yeah, did you work on the mathematical task we have all together? Computing the probability that we are speaking about. Did you do it?
Yeah, I'm currently doing it right now. Actually, in my talk with Ron and Abu previously about my absence, I talked about I had some stuff left right now, so I had to build up a basic understanding first. Then I'm currently working on it right now, so maybe I'll share some updates in this week only.
Yeah, because I'm confused, but I understand that at this point, basically that is the half of the project. Basically, what we have to do is to get ready an algorithm that Simin already have it basically, and to the processing. But the post processing also needs the mathematical analysis, because of course when you estimate something you have to be sure how good is your approximation. So basically that is the main point here, to have the algorithm to test any sample and to have the mathematical analysis that is through the Kramer-Rao bound. Yeah, sure. So if I understand well your status, so you have to update your mathematical understanding up to this point. So to start to look, for example, or to propose a way to disclose the feature information, this from the mathematical side, but from the algorithmic side, of course, you have if you have knowledge about programming, so it could be good if you can improve, if you help to improve the the Simin algorithm that the project has now. I'm not sure if I'm correct, but that is what I understand so far.
Based on what we discussed today, right, Aditya, do you have anything like especially since you're better at coding, I think that you are like more you think you are able to contribute to? Because I also don't really know how to split. Yeah.
Actually, from what I believe, the problem right now is coming in the curve fit, like the curve fit estimate, if I'm correct.
For Christian's code, there is such an issue. Yes. I mean,
No, like
Hmm?
in the overall, like what you mentioned also, like what needs to be more optimized in the code. Like what we are lacking behind in terms of that, because I'll have to review the recording as well, this meeting's recording, like first
because
one.
for my part, like it's kind of okay. It's just more of that. It's 1/3 is approximated to 0.33329, which is not as good as 3333333. You know, yeah, but like that's not like I don't know, like it's not a lot of work. I feel it's more of a later mathematical analysis part. Almost already, I feel. Because she was saying that with increasing the number of qubits, like, oh, you can get how much accuracy, that kind of thing. She was showing the curves for that part too. Yeah. I'm not sure if that's work for right now, other than playing with it. I don't know. I think we can just try to figure it out, I guess.
Maybe like I can ask Ron about something of like what we can venture out in terms of that, because he mentioned like when we was talking about distributing work, like maybe you can one person can tackle like multiple eigenstate values and one person can tackle one eigenstate value. Maybe he was talking about that, so maybe I can give him a message about where we can work forwards in terms of the repository only.
Oh, okay. Actually, now that you mentioned that, I think I okay. How much are you done with your math portion? Like with with calculating the general case probability, because we will need that for the multiple eigen case.
I'm reading rereading the paper right now. I also read the like the references mentioned in that. So I was reading this book that was mentioned in the notes. Then I found another book on that. So I'm currently, making my case towards the Kramer-Rao bound at the moment.
Oh, but what about like the whole like developing the probability for the general case?
Yeah. Actually, I read the equation they used. I understood what they were doing, but maybe like if we have to work on it ourselves, I would need a bit like this week also. I'll be done. Like I'll understand what they were doing.
Okay. Then I think that for Adit, yeah, I feel like it's quite reasonable if you want to work on like if we want to work on like the multiple eigen stuff and you want to work on that, I think you do need to have the mathematical like foundation to that. So like maybe you just try to finish up the math homework that Ron gave during the first meeting, like try by this week. And then afterwards, I feel like then you're in much better state to continue with like the multiple case and stuff.
Oh, yeah.
That's your plan?
Yeah, that would be great.
Yeah. Just a note also is that if you don't understand stuff, like you can ask in the chat, because most of us have like done that. Or also you can also check on other people's like our previous reports, because we basically wrote how to do that. Yeah.
Yeah. I was reviewing the messages as well when writing my weekly reports also.
Yeah. Just so I think you can just try to finish the math homework. Then afterwards we can discuss again and then like see where we are by the next week. Then do like we can do the single case, the single phase case, the multiple phase case, and also the Christian is working on the Fisher information. Yeah, I think yeah. So basically, I'll send. Should I send or do y'all want to send to Ron? I could send. I have written it down. So I think for this week, Christian is working more on the Fisher information. Of course, like you're free to work on other stuff too, but like that one is our goal. Yeah, and then I'll look more into like maybe I can expand my case for more than one phase, and then yeah, that look into that curve fit situation. And then I think for Aditya, I think Aditya can try to quickly finish the math portion. Then after we can discuss again on how to split work after that. Is the plan? Yeah. Okay. Should we ask Ron to come in to get the recording, or should we just?
Maybe I'll let if he can just give a message on Slack. If he can join, then that would be all right. But other than that, it is what it is.
Is anyone messaging Ron? I think we can
Maybe
message. You can if you want to.
Acha, okay.
Why did Ron tag two people from Classic? This is very scary. In Slack. Are you messaging?
Yeah, I'm writing the message right now.
Okay. Also, Christian, are you deriving the Fisher information for the general case or for the single phase case? Or are you doing it for both?
No, good question. I think I'm going to do it on the single phase cases personally. Mhm.
Okay. Then, like, in the
Yeah.
future, we can look at the...
Yeah, sure. So before starting to compute it, I need to understand what way of computing feature information is better for us, because in some reference I have read, there are different ways of computing it. So I'm not sure if I think all of the ways go to the same result. But perhaps speaking about the complexity of the mathematical computing, perhaps there is a way better than other. So I have to clarify that, and after that I will start to compute.
Okay.
But for the single phase, yeah.
Okay. Yeah. Yeah, I wrote that though. I wonder what Ron is doing with the two other Classic people in the other chat. I'll type the message about the group work allocation, by the way.
So do you think that if we leave the meeting, the recording is not saved? Or
I'm not sure, but if you're busy, you can go first. I think I can sit here for another 10 minutes, I guess.
okay.
Yeah, if one person is in the meeting, then the meeting goes on. So
Yeah, if you're busy, you can go first.
yeah, if you're also busy, I can stay in the meeting. I'll leave it on in the background also.
I think I can sit here. It's like 12:30 here. There's nothing much to do at 12:30.
Okay, so I'm going to leave the meeting because here in Colombia is 11:30, so I have to pick up my children from the school. Yeah.
That's good.
So,
Bye.
bye. See you, and thank you.
Thank you. I'm still here typing up the message. More than one space. Have you tried out the math one, by the way? Like, are you like stuck in any, like for the math homework? Like, basically, that's what you're gonna work on for this week, right? Are you stuck in any particular place?
So actually, when we started in the first 2 weeks, I had to go to bed rest, so I left. I didn't do much progress during that time. Actually, to say I just graduated high school, so I'm at the high school level only. So I had to start from the basics in understanding the probability and other stuff. So I'm in that way right now. Actually, took a bunch of different things in between also. So like in the Q cousin, like under Q world, there's different Q cousins. So like QUAE, I was working with them for a while, where they're like building up a syllabus with NYU Abu Dhabi campus. So that took a backseat as well. So they were like, I got a little busy in that stuff as well. So it took a backseat at the moment.
Yeah, that's okay. I was just asking if you were having any trouble with the math, because maybe I could like try to help right now if there's anything. If not, I mean, you can just look at it first, I guess. Yeah.
Doing math here as well. Actually, I have this whiteboard right beside me. So like whenever I'm free, I'm like trying to figure out the equations as well.
Yeah, by the way, it's basically the math homework which Ron gave in that slide. So like you just look at that slide and then see our password, and yeah, it's that one that I'm talking about. Yeah, it's quite applicable to what we're doing right now. Hence, I mentioned it. Yeah.
Yeah. So I was also looking at the like different equations mentioned in the dual frequency paper, like what they were doing basically.
Oh, that paper, the equations are mostly like the front part, it looks similar, but it also will confuse you a bit. So don't get too confused about it. I think it's more useful to see other people's work, like in the group, like for Christian's work is good. Like quite a few of the other members from the other group, their work was quite good too. Like I actually feel like I learned a lot from reading their work. I didn't copy, I like read, then after wrote on my own, that kind. Yeah, but yeah, so that's one way if you're stuck in any place.
I also like there's this startup in India which was doing finance with quantum computing. So like Q Finance, but they were using like QLex SDK. So I was working with them as well, but I didn't wanted to go in the like applications part in this project this time. So I went with the theory instead because I'm looking to move into theory in college.
Yeah, that's me right now in college.
NUS, I know a couple of people from NUS actually applied to the ST Yao award. So there were like few winners from NUS that were winners actually.
Yeah. It is. Will it be very challenging to say finish the math probabilities by this week for you? Do you think you can try? Oh, you're muted. Oh, you're muted.
Sorry. Yeah, I just drank the math this week. I couldn't last week because I had to go to like these exams in the morning. But now I have time. I'll just stay awake all night. I'll run some midnight oil.
Okay. Oh,
I'll get it done.
all right then. Oh no. Why? Okay, wait.
So like I don't think like Ron is checking the Slack at the moment. Should I maybe join the application meeting and give him the message, or like that would be too much?
I'm not sure. I feel like in a way that would be rude, but also like, what if he doesn't check it at all even after he leaves that meeting? Yeah, I'm not sure. Okay, I just sent a message for the group work allocation thing. So like you could check it if you want. I mean, I could edit it if you, yeah.